If you walk into a modern dealership today, you might briefly forget that you are there to buy a pickup truck. You are greeted by massive touchscreens, leather seats with heating and cooling functions, ambient lighting, multi-speaker audio systems, and an endless list of sensors designed to park the vehicle for you. Modern pickups offer more comfort, technology, safety features, and performance than ever before. They have essentially become luxury cars with cargo beds attached to the back. But underneath all that polished leather and behind those bright screens, there is a hidden cost that few buyers think about until years later. Greater complexity means more potential points of failure. When a highly sophisticated sensor fails, or when a complex electronic module stops communicating, the repair bill can easily rival the cost of a luxury vacation. The very technology designed to make modern trucks smoother and more capable has also made them fragile, expensive to maintain, and heavily dependent on specialized equipment. But there was a time when pickup trucks were built with a completely different philosophy. Older work-oriented trucks took a different approach. They were built with generous mechanical margins, kept their systems relatively simple, and prioritized durability over convenience. They were not designed to impress people in a showroom. They were designed to work hard, remain easy to repair, and keep going long after their luxury features had become outdated. Today, we are going to look at 10 budget trucks that feature engines so overbuilt and mechanically simple that they have earned the reputation of being practically eternal. These are the trucks that can still put modern luxury models to shame, not by offering a smoother ride, but by simply refusing to break down. To understand why these older trucks have become so legendary, we first need to understand the engineering philosophy of the past. Decades ago, pickup trucks were viewed strictly as tools. They were purchased by farmers, construction workers, and tradespeople who needed a vehicle that could withstand abuse every single day. The engines inside these trucks were not pushed to their absolute limits to extract maximum horsepower. Instead, engineers designed heavy cast iron blocks, robust internal components, and simple fuel delivery systems that could handle poor quality fuel, extreme temperatures, and long periods of continuous operation. There were no turbochargers spinning at incredible speeds, no high-pressure fuel pumps pushing fuel through microscopic holes, and no complex emission systems choking the exhaust. If something broke, it was usually a mechanical part that could be replaced with basic hand tools in a driveway or a remote field. This simplicity was not a result of a lack of engineering knowledge. It was an intentional choice to build machines that prioritized longevity over peak performance. That is why, with proper maintenance, several of these trucks can remain on the road for hundreds of thousands of kilometers, making them potentially more practical and affordable than newer, technology-heavy pickups. Let us begin with a truck that perfectly represents the transition between old-school simplicity and modern utility, the Ford Ranger produced between 1998 and 2011. During this era, the compact pickup market was highly competitive, but Ford took an approach that relied heavily on proven, rugged engineering. The engines found in these Rangers, including units developed in collaboration with Mazda Engineering, were designed around relatively simple mechanical systems. The 2.3-liter Duratec inline-4 engine, for example, became a favorite among those who valued dependability. It was an engine with a simple overhead cam design, a cast iron block, and a timing chain instead of a belt. This meant there were fewer maintenance intervals to worry about and less chance of catastrophic failure if a part was neglected. The chassis of the Ranger was also straightforward, using a solid front axle setup in earlier years and a robust twin I-beam suspension that could absorb massive amounts of punishment without requiring expensive alignments or complex bushings. These trucks could be maintained without the complexity found in many newer vehicles. They did not require a computer scanner to diagnose a misfire, and they did not lock you out of your own engine bay if an electronic key failed. The Ranger from this era is still frequently praised because it represents a time when a truck was simply a machine designed to do a job, and it did that job without complaining. Moving from America to Japan, the Mitsubishi L200 has earned a similar reputation, particularly in demanding environments where reliability is more important than luxury equipment. The L200 became a global workhorse, favored in regions with challenging terrain, from the muddy roads of Southeast Asia to the frozen paths of Northern Europe. The secret behind the L200's legendary status lies in its 4D56 engine. This 2.5-liter turbodiesel engine was introduced in the 1980s and continued to be used in various forms for decades. It was a completely mechanical diesel engine. There were no electronic control units managing the fuel injection. Fuel was delivered through a mechanical injection pump that relied on pressure and timing rather than microprocessors. What made the 4D56 so special was its sheer overbuilt nature. The internal components were thick and heavy, designed to handle the high compression ratios of diesel combustion without fracturing. Even the early versions with turbochargers were tuned conservatively, meaning the turbo was not spinning fast enough to generate dangerous amounts of heat or pressure. Because of its rugged construction, the L200 became a popular choice for mining companies, agricultural businesses, and anyone who needed a vehicle that could operate continuously in harsh conditions. While the interior was basic and the ride was stiff, the engine under the hood was practically bulletproof. Drivers knew that as long as there was fuel in the tank and clean oil in the engine, the L200 would start and get them to their destination. Another Japanese truck that became known as a dependable workhorse is the Nissan Frontier D22. Introduced in the late 1990s, the D22 generation of the Frontier was built during a time when Nissan was focused on producing rugged, straightforward vehicles. The engines offered in this truck, such as the KA24 and the YD25, are highly valued for their straightforward design and ability to accumulate high mileage when properly maintained. The KA24 was a 2.4-liter gasoline engine that had already proven itself in other Nissan models. It used a simple cast iron block and an aluminum cylinder head. It was not a high-revving performance engine. It was designed to produce steady, reliable torque at low RPMs, which is exactly what a utility vehicle needs. The YD25, on the other hand, provided a diesel option that offered excellent fuel economy and durability. The internals of these engines were designed with generous tolerances, meaning they did not have to be perfectly machined to operate efficiently. This also meant that as the engine aged and parts naturally wore down, the truck could still run relatively smoothly. The Frontier D22 did not have the most comfortable seats or the quietest cabin, but it had a chassis that could carry heavy loads without bending and an engine that would rarely leave its owner stranded. This truck built its reputation not through marketing, but through years of silent, dependable service on job sites and rural roads. Sometimes, the most durable engineering is found not in specialized heavy-duty trucks, but in vehicles that were designed from the ground up to be as simple as possible. The Toyota Tacoma from 1995 to 2004 is another classic example of mechanical simplicity. These trucks have developed strong resale values because of their reputation for durability, relatively straightforward mechanics, and ability to remain useful for decades. The first generation of the Tacoma came with engines like the 2.4-liter 2RZ FE and the 2.7-liter 3RZ FE. These were four-cylinder gasoline engines that utilized a simple design featuring 2 valves per cylinder and a single overhead camshaft. By keeping the valve count low, Toyota reduced the number of moving parts inside the engine, which directly reduced the chances of something failing. The timing chain used in these engines was heavy and robust, designed to last the lifetime of the vehicle without needing replacement. The electrical system was also minimal. There were no complex body control modules that could drain the battery or prevent the engine from starting. The suspension utilized heavy-duty leaf springs at the rear, capable of carrying massive weights without sagging. Because these trucks were so reliable, they were often passed down through generations. A Tacoma from 1998 can still be seen on the road today, doing exactly what it was built to do. They have become so valuable that owners often refuse to sell them, knowing that finding a modern truck with the same level of dependability would cost a fortune. While Toyota is famous for its gasoline engines, its diesel technology is equally impressive, which brings us to another truck on our list. The Chevrolet D-Max, based heavily on Isuzu engineering, is recognized globally for its exceptional durability. Isuzu has a long history of building commercial vehicles and heavy-duty diesel engines, and they brought that exact same philosophy to the pickup truck market. The engines in the D-Max, particularly the 4JK1 and 4JJ1 turbodiesel's, were designed with robust internal components and a work-focused approach. These engines feature cast iron blocks and heavy-duty forged crankshafts. The fuel system, while slightly more modern than the older fully mechanical pumps, was still designed with longevity in mind. The D-Max was built to withstand demanding use over long periods. It was common for these trucks to be used in mining, agriculture, and remote expedition travel, where failure was not an option. The chassis was fully boxed for rigidity, and the suspension components were oversized compared to what was strictly necessary for normal driving. This over-engineering meant that the truck had a high tolerance for abuse. If an owner missed an oil change by a few thousand kilometers, the engine would not self-destruct. If the truck was driven through deep water or thick dust, the simple electrical connections and sealed bearings could usually survive the exposure. The Chevrolet D-Max proved that a truck did not need to be massive or filled with technology to be incredibly capable. It just needed to be engineered with parts that were stronger than the forces acting upon them. When we talk about overbuilt components and industrial strength, it is impossible to ignore the second-generation Dodge Ram. This truck stands out on our list because it features the legendary 5.9-liter Cummins B-Series diesel engine. The story of this engine is fascinating because it was originally designed with industrial applications in mind. Cummins built this engine to power tractors, excavators, and heavy machinery. It was never intended for a pickup truck. Dodge decided to put this massive inline-six engine into the Ram, and it changed the heavy-duty truck market forever. The 5.9-liter Cummins is heavily built. The engine block is made of thick cast iron, the crankshaft is massive, and the cylinder head is designed to handle immense cylinder pressures. In its earlier 12-valve configuration, the engine was completely mechanical. There was no computer controlling the fuel injection. Instead, it used a mechanical P-pump, a device that relies purely on mechanical timing and fuel pressure to operate. Because it was designed for industrial use, the engine was governed to operate at relatively low RPMs. It produced massive torque at low engine speeds, which meant the internal components did not have to endure the stress of high revolutions. This engine has developed a reputation for extremely high mileage. It is not uncommon to find second-generation Dodge Rams with over 500,000 kilometers on the original engine, and there are documented cases of these trucks exceeding 1 million kilometers when properly maintained. The truck around the engine might rattle, the paint might peel, and the interior might fall apart, but the 5.9-liter Cummins engine will just keep running. It is the ultimate example of an engine that was overbuilt for its application, making it practically eternal. Not all eternal engines are heavy-duty diesels. Sometimes, simplicity itself is the greatest form of durability. The Chevrolet C10 represents an even simpler approach to truck engineering. Dating back to the 1960s and 1970s, the C10 was built during an era when automotive electronics were in their infancy. These trucks featured classic, naturally aspirated engines, such as the 250 inline-six or the legendary 350 small-block V8. These engines were relatively straightforward to maintain and repair. They used carburetors to mix fuel and air, and a traditional distributor with a single ignition coil to create the spark. There were no sensors, no control modules, and no warning lights to tell you something was wrong. You had to rely on the sound and feel of the engine. The beauty of the C10 was its accessibility. Anyone with a basic set of wrenches could adjust the timing, replace the spark plugs, or rebuild the carburetor. The engine bay was massive, leaving plenty of room to work around the components. The truck itself was built with heavy-gauge steel and a simple ladder frame. Because there were so few complex parts, there were very few things that could actually break. Even today, many mechanics recommend the Chevrolet C10 as a first project vehicle because the parts are cheap, the engineering is easy to understand, and the engines are practically indestructible. While it lacks the fuel injection and electronic stability control of modern vehicles, it makes up for it with a level of mechanical purity that is almost impossible to find today. The C10 proves that sometimes the best technology is no technology at all. We can see how manufacturers tried to balance modern emissions requirements with old-school durability. The Volkswagen Amarok is a notable example of this transition. Unlike the small Japanese trucks, the Amarok was designed to be a slightly larger, more capable mid-size pickup. Its strong chassis and six-cylinder diesel engine give it a combination of performance, efficiency, and durability that has made it popular among drivers who prioritize capability over luxury. The 3.0-liter V6 TDI engine found in the Amarok is a remarkable piece of engineering. While it does use modern fuel injection and electronic controls, the core architecture of the engine was built for longevity. The block is heavily ribbed for strength, the pistons are cooled by dedicated oil jets, and the timing chain is robustly engineered. Volkswagen designed this engine to handle the stress of towing heavy loads at high speeds on European highways. The chassis of the Amarok is also incredibly rigid, using high-strength steel to prevent flex under heavy loads. While it offers more comfort and technology than an old Nissan Frontier, it still manages to deliver the durability that truck buyers expect. It shows that a modern truck can still be built to last, provided the manufacturer is willing to invest in high-quality materials and robust engineering rather than just cutting costs. The Amarok has proven that you do not have to give up all modern conveniences to get a truck that will survive hundreds of thousands of kilometers of hard work. Another truck that proves this point is the Chevrolet S10 from 2012 onward. While the S10 name has a long history, the modern version, sold in many global markets, stands out for its 2.8-liter Duramax turbodiesel engine. This engine was designed to provide strong performance while maintaining the durability expected from a work-oriented truck. The 2.8-liter Duramax features a compacted graphite iron block, which is stronger and more durable than traditional cast iron. The engine uses a variable geometry turbocharger to provide power across a wide RPM range, but it is tuned conservatively to ensure long-term reliability. The internal components, such as the crankshaft and connecting rods, are forged to handle the high torque output. Chevrolet engineered this engine to meet stringent modern emission standards while still offering the kind of longevity that diesel engines are known for. The S10 itself is a practical, no-nonsense truck. It does not have the massive size of a full-size American pickup, making it easier to maneuver in tight spaces while still offering excellent payload capacity. The suspension is tuned for work, meaning it is stiff and capable of carrying heavy loads without bottoming out. The S10 with the Duramax engine has become a favorite among tradespeople and fleet operators who need a reliable, fuel-efficient truck that can handle daily abuse. It is a reminder that even in today's highly regulated automotive world, it is still possible to build an engine that is tough enough to last for decades. At the top of this list is a truck that has become a global symbol of indestructibility. The Toyota Hilux is quite possibly the world's most famous example of pickup truck durability. Its reputation comes from years of use in demanding environments where reliability is literally a matter of life and death. From the deserts of the Middle East to the jungles of South America, the Hilux has been used in conditions that would quickly overwhelm less durable vehicles. The secret to the Hilux's legendary status lies in its conservative engineering. Toyota has traditionally used proven technology rather than chasing the latest trends. Engines like the 1KZ, TE, and the later one GD, FTV turbodiesels were designed with heavy-duty components and simple, robust systems. The blocks are thick, the cooling systems are oversized, and the electrical systems are heavily protected against moisture and dust. The Hilux has become synonymous with ruggedness because it was built to survive. It is not uncommon for these trucks to be used in mining operations, carrying heavy loads up steep, unpaved roads day after day. The chassis is designed to flex without cracking, and the suspension components are oversized. Even when neglected, the Hilux has a remarkable ability to keep running. There are countless stories of these trucks being abused, submerged in water, and driven with minimal maintenance, only to start up again the next morning. This level of dependability has made the Hilux a legend. It has proven that a truck does not need to be complicated to be great. It just needs to be engineered with a single focus on surviving whatever the world throws at it. When we look at these 10 trucks, the common theme across all of them is not luxury or cutting-edge technology. It is simplicity, durable components, accessible mechanical systems, and engineering designed to withstand abuse. Modern pickups offer incredible capabilities, but they achieve those capabilities through complex systems that require specialized tools and expensive parts to maintain. The trucks we have discussed took a different path. They were built with generous margins, meaning every component was stronger than it needed to be. They were designed to be fixed, not replaced. If a fuel pump failed on an old Mitsubishi L200, a mechanic could rebuild it. If a sensor fails on a modern truck, the vehicle might not even start, and replacing the part requires a computer to reprogram the system. For buyers searching for a long-lasting pickup, the most impressive truck is not necessarily the newest or most expensive one. The truth is, the best engineering is often found in a vehicle that was designed to work hard, remain easy to repair, and keep going long after the luxury features have become outdated. These 10 trucks serve as a reminder that true value in a vehicle is not found in a touchscreen or a leather seat. It is found under the hood, in the heavy iron block, and the simple mechanical systems that refuse to quit. As the automotive world moves further into complex electric systems and autonomous driving, the appeal of these simple, eternal engines will only continue to grow. They represent a time when trucks were built by engineers for workers, and when the measure of a good vehicle was not how fast it could go, but how long it could last.